Okay, let's kick things off with a question that I admit sounds a little out there. But stick with me because the answer could literally save thousands of lives. The question is this: can old tires, the ones just lying around, actually save lives?
Before we get to the how, I want you to just look at this number, 51%. Just let that sit there for a second. What in the world could that be about?
Well, that number represents this. In a place like Turkey, a mind-boggling 51% of all buildings are made with a type of construction that is just dangerously weak when it comes to earthquakes. So when the ground starts to shake, they can just crumble. So yeah, we are talking about a problem that affects millions and millions of people. And the hidden danger? It's something called unreinforced masonry. Basically, think of it like this. You've got bricks and mortar, but that's it. There's no steel, no rebar, nothing inside to handle the pulling apart forces, what engineers call tension, that you get in an earthquake. And that makes these buildings incredibly brittle. And here's the part that really hits home. The folks living in these houses, the vast majority of them are low-income families. So you can't just throw some super expensive high-tech fix at this problem. Whatever the solution is, it has to be cheap, it has to be easy to get, and it has to be simple enough for people to use themselves, right in their own communities. Okay, and this is where the story gets really, really cool. Our hero isn't some fancy new material or a complicated steel structure. Nope, it's this, the humble scrap tire. I mean, think about it. It's a waste product that's literally everywhere on the planet, and a lot of the time, you can get them for free. So how in the world does a tire help? Well, the science behind it is a concept called post-tensioning, and it's actually way simpler than it sounds. Imagine you have a stack of Jenga blocks. Pretty wobbly, right? But what if you wrap a really tight rubber band around them? All of a sudden, that stack is solid. That's post-tensioning. You're basically squeezing the building together to make it strong against any forces trying to pull it apart. And check out how simple this is to actually make. First, you just cut the sides off a tire, leaving you with the tread part. They call this a scrap tire ring, or STR. Then, you link these rings together using some basic steel pipes and bolts, nothing fancy. And finally, you just tighten the bolts with a regular wrench. As you tighten, it stretches the tire chain, creating this incredible amount of tension. No special tools needed. It's brilliant. So what do you do with these chains? You wrap them around the house. You go both vertically and horizontally, creating what's essentially a tight cage around the whole building. This does two things. It holds the walls in, and, this is the really important part, it keeps the corners from pulling apart. And that is so critical because corner separation is one of the main reasons these buildings collapse so catastrophically. All right, so the theory is amazing. It's simple, it's cheap, it sounds perfect. But does it actually work when the ground starts shaking for real? Well, there's only one way to find out. It's time to take this to the lab and put it on a giant shake table. First up, we have our control group. This is a model of a standard, unstrengthened masonry house. This is our baseline. This represents millions of real homes out there right now. Okay, the shake table starts moving, and it doesn't take long. At an acceleration that's basically a sharp jolt, you can already see these big diagonal cracks starting to form. Yeah, that building is in serious trouble. And then, boom, just a little more force, and the whole thing comes down. It's a total, sudden, brittle collapse. See how it doesn't bend? It just shatters, like glass. This is the kind of catastrophic failure that gives people inside absolutely no time to escape. All right, now for the main event. We have an identical house, but this one is wrapped in those scrap tire straps. They're going to run the exact same shake program, so how's it going to do? And here we go. This is the critical moment. The shake table is now at the exact point where the other house just turned to dust. And look at that. The tire-strengthened house is fine. It is still standing. But they didn't stop there, of course not. They cranked up the intensity, pushing it harder and harder, all the way up to a force more than double what destroyed the first house. And you can see, yeah, it's got some cracks, but it did not collapse. The scrap tires literally more than doubled its resilience. And this brings us to what might be the single most important point of all of this. It's not just that the house is stronger, it's that the tires completely change how it fails. It's the difference between what's called a brittle failure and ductile performance. Let me break that down, because this is literally the difference between life and death. Without the tires, you get that brittle failure we saw. the house just shatters instantly. But with the tires, you get ductile performance. That means the building cracks, it bends, it absorbs all that energy, but it stays together. And that gives the people inside precious, precious seconds to get out. And believe it or not, the genius of this idea doesn't even stop there. The same team looked into another amazing use for scrap tires, something called seismic base isolation. It's a really smart technique where you basically decouple the building from its foundation. Think of it like putting the house on roller skates. So when the ground shakes like crazy, the house itself stays pretty still. And their low-cost version of this, it's incredible. You just stack layers of that same tire tread to create what they call scrap tire pads. You place these pads between the foundation and the house. And the crazy part is, when they tested them, these homemade pads worked just as well as super expensive commercial isolators that cost a fortune. It's just amazing. And this isn't just some cool experiment stuck in a lab. This technology is already out in the real world. It's been used to protect school buildings and the kids inside them in places like Turkey and Nicaragua. This is real-world proof that this simple idea could save lives all over the globe. So let's just run down the advantages here, because they're huge. First, it's incredibly cheap. Second, it uses garbage, a waste product that we have everywhere. Third, the tech is so simple anyone can do it. It's good for the environment, and most importantly, we just saw the proof. It works. It really, really works. Even the researchers who did the study concluded that this method is, and I'm quoting them here, a very promising alternative. That's their official take on how we can strengthen some of the most vulnerable buildings on the planet. It really makes you think, doesn't it? Most of us would look at a pile of old tires and just see trash, but these engineers saw a life-saving technology. And it leaves you with this one big question. How many other simple, game-changing solutions are out there just hiding in plain sight, waiting for someone to look at them a little differently?